Hello and welcome to this AIM webinar on the latest on standards in our industry. AIM is the global industry alliance for stakeholders of RFID, barcoding, smart devices, and other automatic identification and data capture technologies supporting blockchain, IoT, and RTLS applications. We represent all industries and organizations that use, implement, resell, or develop technology. We are essential to enabling adoption, growth, and interoperability to those who depend on accurate, available, and identifiable data. AIM creates standards, promotes community, advocates, and educates. Before we get started, there are a few housekeeping slides I would like to go over. It's the policy of AIM Inc. to conduct its operations in strict compliance with the antitrust laws. No AIM activity shall create even the appearance of a violation of the letter or spirit of the antitrust laws. And AIM committee meetings or webinars like today are held for the primary purpose of advancements in our industry, which necessarily involves development of work product intended solely for the public domain. AIM's developed this policy for the protection of its members who engage in this important collaborative effort. Lastly, you'll notice that you are muted, but we do want you to participate on this webinar. Anytime throughout the presentations, you can send us your questions by using the Q&A option at the bottom of the application screen. We will be answering questions at the conclusion of our final presenter. This webinar also is being recorded and you will be notified when it is available. The PowerPoint slides you see now will also be available after the webinar in PDF format. So who is presenting today? Well, it is four individuals who have great knowledge and have helped create and promote many of the industry standards utilized today. First, I'd like to introduce to you Sprague Ackley, Principal Research and Development Engineer at Digimarc. Mr. Ackley participates on the Barcode Technology Committees of ISO, GS1, and AIM. Next, we have Terry Burton, founder of Terry Burton Consulting. Terry is the current AIM Technical Symbology Group Chair and has been a critical voice in the development of the Barcode Symbology, which he'll be discussing later on. Next, we have Clive Hoberger, who is consultant and emeritus member of AIM. Clive is the designer of Ultracode, which he will be discussing later on. And lastly, we have Bill Hoffman, who is Managing Director of Hoffman Systems, LLC, and is representing the Automotive Industry Action Group. Bill has extensive experience in RFID and barcode systems and integration. So let's get things kicked off with Sprague Ackley as he discusses the changes in the ISO barcode world. Sprague, take it away.
Thank you, Mike. Hello, everyone, and welcome to our humble webinar. I'm honored to present on behalf of AIM and tell you a little bit about the ISO standards in Workgroup 1. Okay, next. So as overview of my talk, I'm going to give you a little background on where the Workgroup 1 barcode world comes from, some of the new symbologies that we are working on, and the other aspect of our technology, which is print quality, and then a little bit of a look out to the future. Next. So ISO is the International Organization for Standards, or International Standards Organization, as I like to remember it, but there's many other ways that the name can be construed. But the bottom line is Workgroup 1 is the technical committee, subcommittee of Subcommittee 31, and we are responsible for the barcode symbology standards and print quality. Next. So we were started in the late 90s, and our first meeting we focused on EA and UPC symbology. Back then it was EAN on one side of the pond and UPC on the other side of the pond, and there was a number of variations, and we wanted to establish a single standard for worldwide use. Obviously a successful endeavor. Next. So as time went on, we worked on some of the other very well-known symbologies like Code 128 and Code 39, and then got into the 2D symbologies. The one on the right there, of course, is very familiar to everyone today, but it was completely unknown when we first did the standardization effort. And we had a parallel effort in Europe with CEN TC225, which was really helpful in getting the collaboration across the Atlantic. And actually at that time, AIM was extremely helpful also in funding the travel for the technologists to work on these standards. Next. The other side of Workgroup 1, which actually started as Workgroup 3, was the development of print quality standards. That figure in the upper left there is a scan reflectance profile, was invented by the ANSI committee and published as X3 182. That was the first barcode quality standard that was published in the early 90s. And it became ISOized, as we would like to say, was one of the first print quality standards. And then we developed a 2D version for the 2D symbologies, and then one for DPM, also led by AIM. And the purpose of these standards, of course, is to define a consistent way to measure quality. And then we also have conformance standards, which is essentially a way to ensure that the verifiers out there are consistent. Next. So recently, and who would have ever thought we'd have new barcode symbologies after such a, we have so many, but there's always room for improvement. And we have just published now a symbology called Hanzin code, which I'll talk briefly about. It's super efficient at encoding Chinese characters. And then the addition of rectangular versions for marking on on test tubes and surgical instruments and such were added after that. And DMRE has been published, and the QR code version is getting close to publication. And finally, Jb Code, getting close to publication, is the first ISO symbology that uses color to increase the data density. Next. So there's a picture of Hanzin code there on the right. It's similar in many ways to QR code in its structure, and it has a number of variations, multiple levels of error correction, and is fairly widely used in China at this time, and promises to be a big help in getting 2D barcode throughout Asia. Next. DMRE, which is based entirely on data matrix, and data matrix already has a few rectangular formats, but it really didn't have any long skinny ones, as is shown there on the right. And it has all the advantages of data matrix in terms of it has the same error correction and such, so it's fairly easy for scanner manufacturers and printer folks to add it. And it's now, since it's been published, it's become fairly widely supported. Next. And then there is the versions of QR code that are now rectangular. Prior to this, there was no rectangular QR code versions, and you can see the familiar little eye there in the upper left corner and a slightly different one in the lower right, and that allows the scanner to find the symbol and decode it. And all of these symbols are very easy to print, just like the standard barcodes. Next. Jb Code was designed in Germany as a way to get information in a more compressed state, particularly for biometric use, like in, for instance, visa documents and things like that. And it's designed to be read with a color scanner, of course, but as we all know, there's a lot of color scanners out there, and I'm sure you'll hear more about that from Clive, but we all have them in our pockets. Next. So print quality standards, which have been around, a couple of decades and have been very stable, and they have been widely adopted. And when they were conceived, there was just a few verifiers out there, and with the advent of the linear print quality standard and now the 2D standards, it's ubiquitous, and there are verifications that happen millions a day. And what we found was there was some consistency issues. They are all very good at predicting scanner performance, but it's nice to have kind of get exactly the same grade every time you measure a symbol, and that's what we wanted to do to improve things. So in line with this, there are three major changes. There's a number of subtle changes also, and I'll cover those quickly. Next. So the 2D standard, the biggest one of the big changes is we're adding print growth as a graded parameter. We've never had that before. In the 1D world, we use the scanning aperture to take care of this for us. But in the 2D world, where we can measure things with multiple apertures, you can have both of those symbols pass with one of the apertures that you can use, but they're really, really tough to read. So we're gonna take what used to be a print process parameter and make it a graded parameter, and that will help keep those symbols out of the system. Next. In the DPM world, we've added a coaxial lighting, which is very helpful for automated scanning applications. Next. And finally, all of the standards are benefiting from a more finely graded parameter all the way across the board, where we use the decimal grading rather than just A, B, C, and D. So we end up with a much more stable repeatability measurement. Next. So in the future, there's a new barcode symbology called Ultracode, which is pretty cool, and Clive's going to talk more about that. Digital watermarking has been around for about 20 years, and Jb Code is the version that encodes the GS1 data elements, and it is being used for track and trace and authentication, and I'll talk quickly about those. Next. So this is Ultracode, and those two symbols, which look very different, are both readily decodable with some really cool tricks about identifying the colors where they're classified rather than identified. Next. And a couple pictures of digital watermarking. On the left there is you can see those little dots that the scanner can see, but it's completely invisible to the users. And in the middle there, some fabric, which can be marked permanently with the weave. And on the right, that bottle is covered over its entire surface with almost like a frosted mark, and that can be used to sort plastics. And then there's a test ongoing in Copenhagen as we speak doing that. Next. So I hope everyone will, any of you techie types out there will think about joining us. We have members from all over the world, especially if you got some young whippersnappers who are very keen to get into some new technology. This would be really great for us and really great for them. Your company benefits being demonstrated as a leader, and the whole goal of this is to ensure the health and the growth of the barcode industry, and you can contact AIM for more information.
All right, thank you, Sprague.
Yep, so if anyone has questions, please put them in the chat and we can get to them at the end. Thanks, Mike.
Thanks again, Sprague. Clive.
The Ultracode symbology was developed basically around a concept of using color printing And now, particularly with the advent of the smartphone, using the color display of the smartphone rather than printing. Next slide. All right, Ultracode is enabled by and designed by the Color smartphone. The standard Color smartphone is now the world's largest selling color barcode scanner. And rather than designing a totally new scanner, all you'll need to do is download an app to create and read Ultracodes. In 2021, by now people have expectations of electronic color everywhere. Black and white images are used mostly for text display, and QR code, which is very widely used, is really a black and white legacy symbol, which was designed originally for printing, and as you can see, has taken about 20 years to be adopted as a consumer symbol. Mobile phones are increasingly being used as data carriers rather than paper for two things. One is security applications and for things like event ticketing. So AIM ISS Ultracode, which was actually issued as an AIM standard in 2016, and JB Code are public domain symbologies. And Ultracode was a 10-year development. The TSC doesn't just standardize barcodes. The TSC actually engineers and invents barcodes. For example, the entire use of Reed-Solomon in data matrix was entirely introduced by the AIM TSC. Ultracode V2 is an update which has many new features and much more optimization for smartphones. Next slide. The color barcodes have a long history, and particularly if you go into the patent literature, back in the 80s and 90s, early color barcode designers were infatuated with the idea if you used 16 colors or 64 colors, think of all the data density that you could get. And they patented the designs, and the target, of course, was consumer products. All of these symbols were designed for printing only, and anyone that knows the printing art knows that magenta fade is a huge problem with printer inks, which is why your reds fade over time if left in the sunlight. These early designers also largely ignored the symbol scanning problem, and many of them were really unfamiliar with scanning and forgot the fact that scanning is very sensitive to hues, not only caused by fading, but caused by lighting conditions. And the way that they approached the decoding, the amount of computing power you needed was exponentially increased with added colors. And that problem has been solved today, but the lighting problem is still there. So the two color symbologies that have been developed, Ultracode and Jb Code, are now public domain symbologies. Ultracode version 1 was issued in 2016. Jb Code will probably be formally issued in 2022. But Ultracode was a 10-year development involving contributions from many members of the TSC, including the ones here. Next slide. Ultracode was designed for standard CMYK printing processes and for use on sRGB electronic displays. sRGB is a notation for the way color is displayed and color is read on your digital devices. So V2 is really optimized for smartphones, symbol display and scanning. With the beauties of using the smartphone and the fact that it has an active display means that the colors are highly controlled because they're actively produced. They aren't being determined by reflecting room light off of an image. Ultracode was very much designed to support Unicode, 8-bit characters, and multi-byte languages. And its two encoding defaults are 8859/1 and Unicode UTF-8. But Ultracode's internals use a lot of what's called compaction modes to take the data and compress it into fewer code words. And there's also special compaction modes for things like URLs, where things like https://www period is encoded in one symbol code word. Next slide. It's a barcode designed primarily for personal devices. There's certainly no barrier to use it in printed labeling. And in fact, there's a lot of interest in using on consumer packaging. Ultracode is going to be published by AIM probably in early 2022 as version 2 and submitted to ISO WG1, which Sprague just talked about, for consideration as an ISO standard. If you look at the pictures at the bottom, you can see two things. There's very strong black and white framing in here called a guard pattern. And at the left of that, there's a smaller black and white box with a clock track in it and a added pair of tiles which describe how long the right end of the symbol is in case it isn't there when you go to read it. But it's designed with something very important. Each of the characters, which consists of 5 tiles of 5 different colors stacked in rows, 2 rows here, 3 rows there. Each of those characters is designed so to be determined whether it's valid before you go into the Reed-Solomon error correction. And this allows you to treat them differently if you know that it is an erroneous character, because you only need to use 1 Reed-Solomon character to recover the data from it rather than 2, as if it was a totally unknown error somewhere. And that's almost doubles the efficiency of Reed-Solomon error correction. And here are 2 examples. This is a very common one, a true Rho symbology. This, the shapes of the symbols are restricted to what makes sense on standard size electronic displays. And they get taller up to 5 rows, and they get longer roughly to about 80 characters in length. Next. This is a comparison of the same data, okay, the HTTPS in line 2, encoded at the same module size and at similar error correction levels in QR code and in Ultracode. And you can see now the power of color in terms of increasing spatial density. Ultracode is about 9 times the spatial density of black and white QR code. And so these 2 symbols, in comparison, the Ultracode symbol uses about half the area of a QR code symbol. Next. Technical note here, Ultracode symbol character tiles, as shown in the red box here, are columns of 5 colored modules. The colored tiles use only CM, Y, or G. They do not use black or white deliberately. And that way we can keep black particularly for framing information and structural guidance. The second thing is we do not use red or black, okay, red or blue, excuse me, because red and blue are both made up of magenta and either cyan or yellow. And if a red or blue module were to fade, it would look just like a yellow or cyan. And so by not using red or blue, we can determine when a magenta fade has occurred, and the magenta module now fades to white. And since there's no other white in any tile, we can determine that it is a magenta faded symbol and still decode the tile. So one of the other things we did that was a little different, rather than basing everything around 256, we use a prime modulus 283 for encoding Ultracode, which allowed us 256 values for encoding data, in other words, a complete byte, plus 27 other encoding commands. And this allowed us to intermix encoding commands and data without any kinds of escape because of the fact that they were totally different numerical values. And so a 5-pixel tile or 5-module tile can encode about 9 times the spatial density of the same 5 black or white modules. We looked at trading off spatial data density, and we decided it made much more sense for us to make each tile design self-checking. Next. Self-checking means that damaged 5-module tiles can usually be detected by failure of structural rules before we applied Reed-Solomon error correction. And this is a unique feature of Ultracode versus most others, 2D symbologies, matrix symbologies, and makes Ultracode highly efficient in terms of detection of and recovery of symbol damage. Self-checking code words detect damaged tiles as erasures at known locations rather than the more typical errors at unknown locations. And if you want a simple rule is you need 1 Reed-Solomon character to deal with a location and 1 to deal with the error. If you already know the location, then you only need 1 error correction character to correct for the data. So in reality, you can get almost double the error correction efficiency over other 2D symbologies from the same number of Reed-Solomon error correction characters. Next. The plans for Ultracode standardization are as follows. The version 2 standard right now is in final review by the AIM Technical Symbology Commission. Our goal is to send it out for 30-day public review, hopefully in late December or early January at the latest. And pending a successful review at some point in February, the AIM board will review it for publication and issue the V2 standard by AIM. And at that point, we will submit the V2 ISS to ISO for consideration as a standard. Thank you.
Thank you, Clive. Our next speaker is Terry Burton, and he'll be discussing .code 4.0. Terry, take it away.
Thank you, Mike. So in particular, I want to discuss what differentiates the .code specification from other 2D symbologies. I want to introduce an application which is currently using .code, and also just to get you to think about how you might benefit from .code. The main aim really behind this is to just keep .code in mind. I mean, if you don't currently have a use or a need for .code, and you can't really use .code at the moment in the supply chains, then obviously .code is not especially going to be necessary at this moment. But these use cases, the new applications, new regulations come along, and so by having .code framed in people's minds, we make sure that we hit the ground running. So if we some of you may have heard of .code, others may have not. It's not a new symbology. It was designed about 20 years ago by Andy Longacre. It was published as an AIM specification 10 years ago and has been recently updated to address a critical issue, which I'll describe in a little bit more detail later in the talk. Code was designed for seeing the need for high-speed serialized printing of serialized marks. So where each item may have a different mark requirement, and you want to get the get those marks printed on a manufacturing line at a very high rate. So sometimes people say that code is a high-speed barcode, but what does this really mean? Well, speed is a relative concept. So if you ask equipment manufacturers whether they're fast, they'll say yes, but the real question that they'll ask is, well, fast at what? What is it you're asking my equipment to do? And the key point is that printing equipment can be driven at different rates based on the use case. So many traditional 2D barcodes until this time have had very high fidelity printing requirements. So it's necessary to make sure that the modules that you're printing join up. So if you're printing in dots, it may be that you need 4 neighboring dots to really create a square module. It may be that there needs to be some overlap, and it may well be that in both the X and the Y dimensions, you need to really control the process. Of course, the stricter the requirement for the higher fidelity symbols, this leads to a restriction of the velocity of the production line, or at least it may require additional hardware or more lanes in order to parallelize the workload so that the parts of those lanes can go slower. So it's probably better to say that not code is a high-speed barcode, but code is a highly tolerant barcode. It's highly tolerant of the kind of printing defects that you introduce when you drive current technologies for printing marks towards their design limits. So code hopefully will enable you to run your lanes at a higher speed if that is your requirement and reach into those higher speed domains. Next slide, please. Okay, so what is different about barcode? Well, the great thing is we can see a lot of the differences just by looking. So in this slide, we can see that we've got symbols of varying different lengths and heights. Code is always an odd by even checkerboard pattern. There's that leads to this property that if you look at the corners of the symbols, you can see that there are really 6 dots in the corners, because one of the corners will just necessarily have an unprinted dot. So we can think of the other 2 dots which are neighboring that unprinted corner as being the corner dots. It's always a disconnected dot pattern, so it's like a checkerboard pattern. And it's easy to print because the specification is tolerant of those dots being distorted in certain ways. So you can print a dot with a ratio of 2:3 or 3:2 for the X and the Y dimension, and that's fine. That's the range within which the dots must be printing. So if you're going fast and your dots are becoming ovals because the line is moving fast, then code allows you to get away with that. Every dot in the symbol represents a part of the message. You can see there that there's no fixtures such as alignment patterns, and you can see that each dot is important in just representing the information itself. There's not much overhead with code. So the other thing of code, you see the flexibility to symbol sizes there. Other symbologies often come in of a variety of square sizes, but as Sprague was saying earlier, the palette of rectangular sizes is quite often limited. Whereas code is completely flexible. You can pick any dimensions for the height and the width, providing that you pick an odd by even number. And why is this important? Well, CIJ printing as an example technology, if you're printing symbols, you need to quite often slow down if you increase the symbol height, because you have ink being sprayed at a fixed pattern that you're diverting in some means. And the more you have to divert, the slower you have to be to maintain the fidelity and stop the ink from sort of spreading in the horizontal in the direction of the line. So code is a good investment in this sense, because you may start out by producing long ribbons in order to give you that speed on the line. So you have a narrow height, a small height, and a long symbol to give you the maximum throughput. But as you iterate through different improvements in the hardware, and as your sort of the heads and the modules increase in the technology, you can grow that symbol height. So the idea would be that in future you can make the symbol You can move more towards the square symbols if that fits your design constraints for the solution. So next slide, please. So who needs another barcode? Well, dot code was invented 15 years ago, or rather about 20 years ago, but it was 15 years after development that it was actually put into large-scale use. So in the mid-2010s, tobacco manufacturers became aware of some proposed legislation that required serialization of unit packs to defeat counterfeiting of goods. And that's the idea that you have to put a unique code on each product. And in this case, it was that you had to read back each of those codes and put them into a database before the product was shipped. So these lines for the tobacco products will often run in excess of 1,000 units per minute. And this was exceeding the capabilities of many of the existing technologies when generating marks such as data matrix and QR. The good thing was that the people that sort of engaged with this were aware of dot code and had the foresight to realize that, that this was a good fit for the application. And so as a result, the legislation has adopted dot code as a possible carrier on the unit pack, together with QR code at EC level H, and also together with data matrix ECC 200, but not the data matrix rectangular extensions, which are the newly standardized extensions which we're talking about, which Sprague was talking about, which gives you this fine range of rectangular formats, these long thin ribbons, if you like. So really at the moment, dot code is the only symbology which can give you that kind of symbol. So now, as a result, there's many manufacturers and economic operators in the language of the regulation, which are applying dot code symbols to unit packs of cigarettes. So next slide, please. So we already have seen that dot code works in a demanding regulated use case. Other applications may come. AIM wishes its members to maintain a general awareness of the benefits of dot code. So even if you may not be able to use dot code within your own supply chains at the moment, having an awareness of the need is important so that you can keep a watching brief of the things coming down the pipe. And then you can start to rattle the appropriate people's cages if you see that, that dot code could be a good fit for that. So the questions I want to ask is, do you anticipate that you will have new serialization requirements coming either as a result of legislation, or maybe just for some internal processes such as internal sortation and high-speed sortation, which requires you to take your existing equipment and to drive those into the highest speed domains. So if you foresee that, if you foresee a use for that in existing open supply chains, then tell the responsible agencies of this. But for all of the applications, if you see any impediments to using dot code, then please tell AIM or the TSC in particular with contact details that might provide. For example, is lack of international standard specification or vendor support preventing your use of dot code in your area? So if we could have the next slide, please. So one cautionary note is make sure that you're using the latest version. I did mention that the symbology was revised in 2019 as a result of finding some critical flaws. Essentially, you could follow the dot code encoder process properly, but end up with a symbol that was missing at the perimeter edge. And this is a critical issue because it means that such symbols would fail the odd by even criteria, which is required for verification, and there will be no onus on any scanner to be able to read such symbols. Or to put that another way, there are certain rare messages that dot code simply is unable to encode. So you go to encode something just randomly, you create a symbol that cannot be read. So when you go to read it back and put it in your database, it looks like a badly printed symbol potentially, but actually it's just that dot code cannot encode that symbol. So that has been comprehensively fixed. And what we've got on this slide here is just something which we don't need to go into, but the scoring process in the generation of symbols has been amended so that the missing outer edge is taken into account, scored harshly. And in the case that none of the mask candidates, that is the candidate symbols for dot code, hit a sufficiently high math score, we go through a process of lighting those 6 corner dots, which I mentioned earlier in the edges of the symbol, thereby introducing those, ensuring that a missing perimeter edge is reintroduced by the presence of these extra dots in the corners. And this is a comprehensive fix for the issue. So now .code doesn't have this problem of not being able to encode certain messages. Next slide, please. So I said that this is obviously a high-level talk, and that there is a lot more detail available in other resources. So, for example, last year, AIM released a webinar which was focused on .code. And in that webinar, Nadie Gray of GS1 describes in more detail the tobacco product application use case for anti-counterfeiting. And also myself and George Wright IV go into detail about the fixes that were placed into the revision 4.0 specification, which was more than just the fix for this critical issue. There's several other improvements as well. But as ever, AIM would invite you to purchase and look at the revision 4.0 specification for the actual technical details. So I just want to end by thanking you for your attention. And just say that before you run away and review this material, so for you search on YouTube for this webinar, that we'd be happy to entertain any questions at the end of this webinar. So, thank you for your attention.
Thank you, Terry. And last but not least, Bill Hoffman.
Thank you, Mike. It's going to be a tough road to hoe following these 3 giants, I'll tell you, but my task today is to introduce you to those who don't know WG8. ISO JTC1 SC31 WG8 is an interesting organization. Could you, next slide, please. Our responsibility is to apply guidance on how to combine technology standards. And by the way, I don't usually like to read slides, but these are really key, so I'm going to violate my own rule. Our job in WG8, who are very accurate at, my tongue could get to work. Jeannie Duckett is our convener, and she's just recently picked up this task and is doing an excellent job. It's like herding cats, and she does a very good job of it. Because WG8 is made up of a lot of very powerful people, because our job is to take the technology standards that WG1, WG4 can generate, and it used to be 2 and 3. Oh, it is 2, and it used to be 3, and there was others in there. But we take what they make and include quality assessments suitable for global applications of ADC. Basically, we take them and make them work, because just a technology standard, like for a barcode symbol or an RFID tag, they're not sufficient to build a running AIDC application on. You have to have other pieces. So what WG8 does is we take modules from WG1, the data carrier, WG2, the data and structure, and WG4, radio communications. We combine those with the expertise from the committee. And like I said before, we have members of WG1, WG2, WG4 on WG8 that help us understand these underlying principles of the documents we're combining into a functional application standard. And there's the key. These are application standards. We also help other ISO and IEC communities understand what we're attempting to do. And we take what they do as well and combine them into our documents. And I'm kind of adding what I'm going to say in the next slide into this one. So next slide, please. I do this much better when I can face people. Anyway, what our task in the WG8 is to not only take data standards from other committees and combine them, but we assist those committees in applying their work. What's interesting is a lot of times, okay, I'm diverging. Standards aren't just made in a vacuum. They're made for a reason. The reasons are to solve a problem, and the problem has usually many heads. So you need many heads to help solve that problem. WG8 has those many heads, and we assist other committees in understanding the application of their standard. So either they'll reach out, or as many of our members are members of those other committees, they'll say, hey, we have a further insight into this outgrowth of what's going to happen here. So WG8 is a melting pot of ideas and contributions, and our principal focus is develop AIDC application standards. We're also the external focal point for SC31's work. SC31 has published more than 100 international standards in the AIDC area, and they address barcode symbologies, how it's created in red, RFID interface standards, RTLS, unique data content. So there's a plethora of work to be done to take these underlying principles and to turn them into an application that people can use. WG8 currently has a number of projects ongoing, one of which I'm very intimately familiar with because I'm the project editor for it, and that is the 1736X series of standards. Now, when you look at these 4 documents, and there's basically 5, but one of them we turned back over to the big container folk, but 17364 through 17367 deal with a silo, if you want to call it that, but that silo breaches many horizontal areas because it goes from product tagging to product packaging, the thing you put the product into, to transport units, the things you put the product packaged into, and then returnable transport items and returnable packaging items, the continuous supply chain. So those 4 documents deal with the entire product supply chain in a very interesting way, because there were 4 documents that said the same thing about 4 different types of product. When we reviewed this thing the last time, we found that, and because we had to update it, it did not handle 8-bit data, didn't have an application to handle 8-bit data, nor did it have a binary encodation capability either. So we added those. In that work, we found out that, wow, all 4 of these handle data the very same way. Why do we have 4 documents? It was decided at that time, which was 2 years ago, that when we finished these projects individually, because we thought that's the ISO way, that we will then integrate all of these. Well, it turns out that Henri Bartel very kindly told us that, well, no, you don't have to wait. You can go ahead and integrate these at this point in time if the committee so decides. Well, we immediately looked around at each other and said, what are we waiting for? And it was resolved, and a recommendation was put forward to integrate all 4 of these documents into one. We now have a new work item proposal that has been submitted to ISO. It's under ballot at this time. It will be done on December 22 to integrate all 4 of these documents into one document called ISO IEC 17360. It has the very same data handling capability that all of these documents have, because all of these documents have the same data handling capability. But they will cover each individual product as a separate clause, which now we have a much simpler approach to a very critical document, or series of documents in this case, but it will become one, because these documents are held critical by a number of very large industries, the automotive industry being one of them, the Department of Defense being another. The retail industry, believe it or not, is even interested in this, and it just goes on and on. So we have a very large task before us that says, guys, you got to get this done, and you've got to get it done quickly. We have other projects within WG8. Digital representation of product information, 22603. And 8506, AIDC application in industrial construction. This one is huge. Imagine building a very large building using automatic identification data collection. Just think about that a minute. Imagine the benefits you get from knowing where your products are, when they're going to be here, is it the right product at the right time, in the right color, at the right format, all those things that are critical. How do you think the Chinese put together, I think it's at least 3 hospitals in, what was it, 8 weeks? It was a very short period of time. It was a huge process. They used AIDC. They're bringing the work they did to the international community saying, we'd like to make this a standard, and we're all for it. There's also a new work item proposed on Internet of Clothes. Next slide, please. Oh, I have a, yeah, this is a question and comments, but I have a statement that I would like to read. I normally don't do this, but I have, as you can see from the previous presentation, standards development is critical to the success of industry. Because of that, it is critical that you participate in the creation of the structures that you will be required to work with. AIM has numerous committees that deal with a broad range of essential topics. Join us and lend your expertise in defining the future. Thank you.
Thank you, Bill, and thank you to everyone here for presenting today. We do have time for questions or comments. We also have everyone's contact information here if you have specific questions you'd like to ask each of the presenters. So let's start here, Sprague, with you. One of the questions we have is why the slow adoption of AIDC in healthcare provider operations, and how can AIM potentially accelerate that?
Yes, I saw that in the chat. Hi, Nap. I hope you're doing well. Well, I would counter that, you know, healthcare has been the quote unquote killer app really for 30 years. And there was a very slow adoption in the 90s and the early 2000s, but that has ramped up considerably. You know, virtually all healthcare providers use barcoding throughout their facility. You can't go into a hospital anymore and not see barcode. That was greatly assisted by the government insisting that everything be marked with a barcode symbol, which would just identify the item. That was over 10 years ago. Then the unique device identifier, UDI effort forced everyone to mark devices following a standard and put them in machine readable form. And in fact, I think AIM actually has a webinar on UDI. So that's one way AIM is promoting that standard. And now there is a similar thing for drugs. And I think there is a very, very rapid development of applications in healthcare. And I think that will continue. You know, in the early days of barcoding in healthcare, you know, it was more like, you know, do we get a fancy new MRI machine or do we buy some barcode scanners? But you know, now it is the standard operating procedure, and I think we'll see continued expansion of that in healthcare moving forward.
Great, thank you, Sprague. So we got several questions that are very similar, but the first one I will ask to you, Terry, I'll direct it, is what would it take for the widespread adoption of .code, or for more adoption of .code?
I throw that question in some sense back at the audience. I mean, I would really like to hear, or rather the TSC as a whole would really like to hear of use cases where .code could help. So part of the of giving this presentation is to get the cogs turning. It may well be, and probably, you know, it took 15 years before there was any sort of implementations of .code, that those applications are just not right there at this moment. Certainly the regulators and the people who are responsible for supply chains such as GS1 would need to have a very convincing argument and advantage to introduce new symbology into the supply chain, because there's obviously a cost to maintaining compatibility, and there's all the follow-on costs to having equipment and standards implemented for that. But in internal applications, things like high-speed internal sortation, I've heard people saying that maybe sawn timber would be a good application of this, so that the timber sort of that comes off the mill can be labeled at high speed, and then further down the chain identified and sorted. Those kind of applications would be good. I mean, clearly now there are manufacturers which are producing equipment which can produce .code marks. There's clearly manufacturers that can read them. So I don't think that the software and the hardware compatibility issue now is so much an issue. I think the other thing is just the question of what does .code bring to the table that QR and data matrix doesn't. I think the killer feature of .code is that it can probably drive the same technology that would ordinarily generate QR and data matrix at those higher rates. But then if you leave it 2 or 3 years and the technology improves, then you can probably generate the QR and the data matrix at those same rates. So I think the thing is with .code, it gets there first. So the question is, what is the application that is stretching your hardware at the moment, because it's and may continue to do so, because it's likely that those are the applications that .code will prevail in. Hope that gets some cogs turning.
Yep, thank you, Terry. Clive, we had a question about what are the similarities and differences between Ultracode and JB Code, which Sprague had brought up earlier.
Okay, I thought it was regarding QR code versus Ultracode, or these two different things?
Two different ones, yeah.
Okay, as far as JB Code, there is a very big difference between them. First of all, Ultracode is designed to be a general purpose symbology, which can be printed by anything and read by anything, and now anything is fundamentally a cell phone. So I was asked, well, who's going to make a reader for it? And the answer is there's no need to. There's 7 billion of them already out there. The real question is who's going to make an app for it? JB Code is a very special barcode which is invented primarily for documents and to be put on documents to encode special information such as visas and other things. It's not a general purpose barcode. It also requires a printing process that can print not only CMYK, but also RGB colors as well. It's a very powerful symbology and it's very pretty, but it is restricted at this stage, at least in concept, primarily to documents. Whereas Ultracode is designed to be printed on anything and to be scannable by anything. And another difference is the way in which colors are decoded. And Ultracode uses a method called an adaptive classifier, which I originally developed for EEG analysis. And fundamentally, we don't try and measure the color of anything. We take what's there. We know anything that's inside the large black box is color. And so we look at every pixel inside that box and throw it into a bin, which is either CMYK, black or white. And they may not conform to the standard definition of cyan, or they may look more blue, but the point is they are different from the something that looks like red, which was supposed to be magenta. And by doing classification, rather than trying to actually measure the color in the RGB space, we now can be extremely tolerant of both color changes and of lighting conditions, which strongly affect the perceived color in the reader. So that's my general information. They're both fine symbologies, but they're designed for different uses.
Great. And sticking with you, Clive, there was the question. I know you had a slide earlier with Ultracode and QR code, but are there other advantages?
Internally, the two symbologies are very similar. QR code totally broke the mold of the way we design symbologies, because rather than putting the finder patterns out at the edge of the symbol, we now have them in the center of the symbol. And Ultracode definitely uses that, as does Hanjin and QR code and all the derivatives which have come from there. And they're computationally require about the same amount of computation. The way we do decoding in Ultracode minimizes having to have a lot of complex computation. They both use the same Reed-Solomon error correction process. The difference is in the way we encode data and thus the way we decode it. The couple of points is Ultracode has very sophisticated methods of compacting data. By that, I mean taking the binary input data and compacting it down to fewer hexadecimal structures rather than encoding it one for one. And this is particularly powerful in things like Unicode and in URLs. And the last point, and it may sound silly, but it's very true. People like color.
They sure do. Thank you for that, Clive. Another question we did receive, and I guess I'll direct this towards Sprague since he brought it up earlier, is what would it take for the widespread adoption of digital watermarks?
Oh boy, well, that's certainly something we talk about a lot. Well, one thing I'm working on is developing print quality tools that can be used on press. When you have a digital watermark, in many applications you can't see it, so it's kind of a little trickier to measure than a regular barcodes. Also, it's spread all over the surface, so these two things make it a little bit more difficult to for process control. So that's one thing that is a problem that's being worked on that will help widespread adoption. Secondly, it's always good to have the killer app, and one that we are very excited about and is generating huge excitement is the molding of the watermarks into plastics so that they can be automatically sorted in the recycle stream. That turns basically garbage into useful commodity, because once you have pure material, that can be used to make new material. So that application, which I alluded to earlier, it's called the Holy Grail project. It's actually in a industrial use in Copenhagen to test the concept, and that activity is supported by over 100 companies, brands of which you will all recognize. So I think that will go a long way to a widespread adoption. And it's a little, we're a little company, and as Terry and Clive and Bill, everyone has already mentioned, sometimes it takes quite a while from when something is first introduced to when it's actually adopted, like .code. It took 15 years to find a good application, and the Digimarc barcode was only introduced about 5 years ago. So time, quality, and killer apps, I'd say those are three that will help the adoption of Digimarc.
Great, thank you, Sprague. A few more. I know we're past our hour here, but there's a lot of conversation going on in the chat about the need for a standard for barcode wristbands for patients. They're saying, believe it or not, there isn't one available right now. I don't know if you guys have some comments on that as well.
Well, I can throw a quick one out. Having been involved in healthcare applications for a long time, the real problem with that is there's this sensitivity of identifying humans, and hospitals like to keep their their patient identifications proprietary. As far as I'm concerned, there's no reason why it can't be standardized. In fact, it would be a good task for Workgroup 8 that Bill talked about, auto ID applications. I know the HIBIC group and the GS1 healthcare group, they are both working tirelessly to standardize various applications in healthcare. But the real limit is getting everyone to sit down and agree what data elements that can be used. As far as the barcode side of it, there are already standardized barcodes that can be used to identify patients. That's not the problem. It's not the technology issue. It's getting the the provider world to agree on a single data standard.
Great, Sprague. And Clive, did you have something to add to that?
Not to this, but I'd like to go back to what Terry was talking about uses for code. About 20 years ago, when I was still at Zebra, I looked into barcoding of construction materials. And we had an early version of Ultracode, which was black and white and had very good tolerance problems, but wasn't nearly as well designed as code. Things like timber, for example, if you go into a hardware store and buy a 2x4 or 4x4 of womanized lumber, you'll find typically on the end of it a little piece of plastic with a UPC code on it. All right, that costs about 3 cents for the serialized piece, and then there's the effort of stapling it on. We looked into the whole issue. Why not just put it right on the piece of lumber, inkjet it right onto the piece of lumber with something like code. Construction materials are a huge application. Not only, and the barcode doesn't have to be printed in ugly black and white. You can print it in UV or infrared inks, which are invisible to the naked eye. So I would say construction materials is a wonderful application for a simple, easy to print, and easy to read barcode like code.
Great, thank you, Clive. And Terry, one last question about code. Someone looking for clarification. Is code only being used in the EU tobacco industry, and why isn't it adopted in the US per se?
So at the moment, the only use that I'm aware of is in the EU. So yeah, that's an important clarification. The driver for that was part of the World Health Organization's Fight Against Illicit Trade program, which is a global program, so far as I'm aware. And the EU brought in the legislation to go in alignment with that. I'm not sure elsewhere what other regions regulators have done in this regard, but yeah, to the best of my knowledge, it's the EU which have authorized code as a unit pack symbol for tobacco products.
Yeah, it has to do with serialization. The EU is requiring it, and some of the tobacco products just couldn't do it quickly enough and cost effectively enough. So it's been adopted there. It's really a good symbology for any type of serialization, but generally it takes regulation to force people to make that jump, unless there's a super good, very high cost or mission critical type thing driving serialization. But regulation is what did that.
Great. Well, that looks to wrap up our questions and comments for today. I'd like to thank the audience for their active participation. I also want to thank, once again, our expert panel here, Sprague, Clive, Terry, and Bill, for your insights today. It's greatly appreciated. All their contact information is on the screen right now. So if you do have additional questions, please reach out to them. We also have the AIM contact information if you'd like to learn more about what AIM is doing and how to get more involved with AIM or learn more about it. That information is up there as well. Thanks again, panel.
Thanks, Mike, and thanks to everybody for attending. Certainly my pleasure. And I'm sure everyone will agree. It's great fun.
Thank you.
Thank you all.
All right, thanks everyone. Enjoy the rest of your day.
Bye-bye.